the ancient computer that shouldn't exist. What if I told you that 2,000 years ago, someone built a device so advanced, so impossibly complex, that nothing like it would exist again for another 1,400 years? Not a myth, not a legend, a real physical object sitting right now in a museum in Athens, Greece, that has completely rewritten the history of human technology. Scientists have used X-ray machines to see inside it. Astrophysicists have used gravitational wave algorithms to decode it. And yet, the more they study it, the more questions they find. This is the story of the Antikythera mechanism, the world's first computer, and the mystery that still haunts researchers to this day. It's the spring of 1900. A team of Greek sponge divers from the island of Symi are caught in a storm near a tiny, barely known island called Antikythera, sitting in the waters between mainland Greece and Crete. When the storm clears, they dive into the water to look for sponges. What they find instead stops them cold. A shipwreck, ancient, massive. Scattered across the seafloor at about 50 meters deep are marble statues, bronze figures, amphorae, glassware, silver coins, the unmistakable cargo of a Roman trading vessel, wrecked sometime in the 1st century BC. The Greek government sent a naval ship. Over the following year, divers pulled up one of the greatest underwater hauls in archaeological history, dozens of sculptures, priceless artifacts, and then, almost as an afterthought, a corroded lump of bronze. Nobody paid it much attention at first. It was just a thing, a weird, green, calcified rock that nobody could identify. It sat in a back room of the National Archaeological Museum in Athens, largely ignored. Then, in 1902, a Greek archaeologist named Valerios Stais noticed something strange. The lump had gears inside it, bronze gears, precisely cut, intricately interlocked, inside a 2,000-year-old object. The mystery had begun. So, what exactly is the Antikythera mechanism? The device, roughly the size of a shoebox, was originally housed in a wooden case. It contained at least 30 individually hand-cut bronze gears. Some estimates say as many as 37. The largest gear measured 140 millimeters in diameter. The smallest, just 45 millimeters. Each gear tooth was filed by hand. The average thickness of the gear wheels, just 1.4 millimeters, with a gap between gears of barely 1.2 millimeters, the width of a human hair thread. On the front face, there were 2 dials, an outer ring marked with a 365-day Egyptian calendar, and an inner movable ring showing the Greek zodiac, adjustable to compensate for leap years. Pointers moved across these scales as a hand crank was turned, showing the positions of the sun and moon in real time. There was also a small rotating ball, half silver, half black, that displayed the current phase of the moon. Every night, as you turned the crank, the ball would rotate to show you exactly what the moon looked like in the sky. On the back, 2 large spiral dials tracked longer astronomical cycles. The upper back dial tracked the Metonic cycle, 235 lunar months, or 19 solar years, the period after which the lunar and solar calendars align again. The lower back dial predicted eclipses using the Saros cycle, the 223-month interval after which solar and lunar eclipses repeat in nearly identical patterns. There was also a smaller dial tracking the Olympiad cycle, the 4-year schedule of the ancient Olympic and Panhellenic Games. But here's what makes this machine truly mind-bending. The gear system that drove the lunar pointer didn't just track the moon's average speed. It used a sophisticated pin and slot mechanism, a form of epicyclic gearing, to simulate the fact that the moon speeds up and slows down as it moves through its elliptical orbit. That level of precision, that mathematical nuance, it wasn't rediscovered by European engineers until the 14th century AD. We're talking about a 1,400-year gap in human technology. Let that sink in. For decades after its discovery, the Antikythera mechanism was barely understood. The fragments kept breaking apart. Conventional analysis couldn't penetrate the corroded surface. Then in the 1970s, British physicist Derek de Solla Price did something radical. He commissioned X-ray scans of the fragments. What he found inside stunned him. 30 distinct gears, interconnected in ways that shouldn't have been possible in antiquity. In 1974, he published a landmark paper, Gears from the Greeks. He had cracked the surface, but huge mysteries remained. The real breakthrough came in 2005, when an international research team called the Antikythera Mechanism Research Project used high-resolution X-ray computed tomography, essentially a 3D medical CT scan, to see inside every fragment without dismantling them. They discovered previously unread inscriptions buried within the corroded layers, gear arrangements that nobody knew existed, a front display system that could track the positions of all 5 planets visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. In 2021, a team at University College London published the most complete reconstruction yet. They identified a compact epicyclic gear system for the planetary display, 30 precision gears packed into a space the size of your palm. And then, in 2024, something truly unexpected happened. Astronomers from the University of Glasgow, scientists who normally study gravitational waves and black holes, applied their algorithms to one of the mechanism's broken calendar rings to figure out how many holes it originally had. Their conclusion? 354 holes, matching the Greek lunar calendar almost exactly. The ring wasn't tracking the solar year at all. It was tracking the moon. Science had to borrow tools built for detecting ripples from colliding black holes, to decode a 2,000-year-old bronze clock